topic. So perhaps at this point, we might want to start because we have a very busy afternoon ahead of us. So welcome everyone. For those of you who have just joined us, my name is Lise Jaillant. I'm a senior lecturer in digital humanities at Loughborough University. And it is my great pleasure to chair this session with two wonderful speakers. So we have Ryan Cordell and Ahmed El Gamal. So I'm just going to say a few words to introduce first Ryan. So Ryan Cordell is an associate professor in the School of Information Sciences at the University of Illinois in the US. So it's still quite early, I imagine, in the US right now. So thank you for being here today. And of course, many of you will know that Ryan is the author of the Library of Congress report on machine learning applied to the library sector. So it's very relevant to this event today on AI and cultural heritage. And we are very happy to have Ryan with us right now. And also we will follow on with Ahmed El Gamal. So just to say a few words to introduce Ahmed. So Ahmed El Gamal is a professor in the Department of Computer Science at Rutgers University, so of course also in the US. So we are delighted to have a computer scientist with us today. Ahmed is a founder and director of the Art and Artificial Intelligence Laboratory at Rutgers, and this lab focuses on data science in the area of digital humanities. So obviously very relevant to this event today as well. So thank you so much, Ryan and Ahmed. Perhaps we can start with Ryan, and you told me you have slides you wanted to share.
Yes, great. So can people see my slides now? Okay. And advancing slides works. Great. Okay. The other day I was presenting and when I advanced my slides, no one was seeing it apparently. So yeah, it is early here. If there's noise in the background, I apologize. It's my family getting ready for school. I've tried to find the quietest corner of the house that I can. Yeah, so in 2020, I was commissioned by the Library of Congress to write a report outlining the current state of machine learning in libraries and to clarify the primary challenges facing this work currently and offer recommendations to guide future library machine learning projects. The majority of machine learning experiments in libraries or using library collections stems from the simple reality that human time, attention, and labor will always be limited in proportion to the enormous collections that we might wish to describe or to catalog. Machine learning methods are proposed as tools for enriching collections or making them more usable for scholars, students, and the general public. The recommendations in my report seek to address many potential intersections of libraries and machine learning, from libraries' public mission, which might inspire programs that could bolster public literacy about machine learning or AI, to libraries' research agendas, which might sponsor machine learning experiments that foster new modes for exploring or analyzing library collections. In the report, in short, I advocate that libraries and information science professionals take leadership roles in current machine learning conversations, both as practitioners and as advocates. In my very brief remarks today, I want to expand one core idea from this report, arguing that if libraries seek to be leaders in broader machine learning conversations, we must narrow the gap separating promises that machine learning will enhance discoverability for library materials and the library systems through which most users encounter those materials. In the report, I noted that despite the level of attention it's received recently, machine learning has a long history in libraries, going back in explicit terms to at least the 1970s and further back if we broaden our definition. Indeed, some of the most massive digital library collections were developed in tandem with and rely on one of the most ubiquitous machine learning technologies, one that's so ubiquitous that we often fail to include it when we're talking about machine learning or AI, which is optical character recognition, or OCR. Aside from a few exceptions like OCR, however, in the report, I described the, quote, perpetual future tense of most machine learning experiments even in 2022. In project and grant applications, machine learning projects promise to enhance collection metadata, to illuminate new connections between holdings, or to generate alternative user interfaces for navigating and exploring collections. And then looking forward, the literature points to a time when machine learning will be incorporated into library workflows that structure core discovery or research experiments. So a project might propose to automatically improve the metadata in a catalog of photographs, for instance, by extracting embedded text or identifying subjects or simply identifying the compositional palette of the images. At present, however, the results of most machine learning research tends to end up in data or code repositories separate from the digital libraries from which they drew their data, and where the research findings will only be seen by a few other more technically inclined researchers. Machine learning research products are rarely ingested or incorporated into core library interfaces through which most users, students, or domain researchers encounter collections, such that the contributions of machine learning to discoverability remain largely theoretical rather than practical. To frame this another way, the push to make research claims about the content of digital libraries, claims that domain experts might push back against or argue with, perhaps obscures the most substantial contribution that machine learning could make to cultural heritage collections, which is to enable new modes of browsing, relating, or serendipity for researchers, students, and the general public. A reason that the research to interface loop rarely closes is that within libraries, one finds significant anxiety about the reliability of machine learning derived data. Librarians and researchers alike reckon throughout the literature with the consequences of information created through probabilistic means. As I ask in the report, how can the reliability of machine learning data and metadata be assessed? And how can probabilistic information be integrated with human created information or integrated into systems designed around hand-assigned categories, tags, summaries, and so forth? To phrase this question another way, how might we bridge a world that prioritizes expert data and metadata created slowly with a set of methods that generate useful but flawed data and metadata more quickly and at a larger scale? So even as machine learning methods have grown more powerful, nuanced, and sophisticated, ambitious hopes that machine learning might better identify or describe library collections have been largely unmet from the perspective of most users. Developing more iterative, experimental, and even speculative interfaces that allow users to explore collections through machine learning-derived patterns can enhance library data while educating users about machine learning processes, decisions, and biases. So I want to kind of home in on this one specific recommendation that I make in the report, and I'll zoom into sort of the key part of it because I know it might be hard to read. I'm not sure how I'm projecting at the moment. So here, this recommendation to pilot integrated interfaces for communicating machine learning derived data, and saying that those interfaces should report things like the confidence scores for the algorithms that were used for the algorithms that were used for whatever the task is, whether that's genre classification, image sorting, identification, so on and so forth. And the idea here being that these interfaces are both about allowing users to explore whatever the primary data is, whether it's books or images or what have you, but also are a way of sort of subtly or even not subtly communicating what these machine learning processes are and doing a bit of literacy work as people are browsing these collections. So I echo here that a generative bridge between the worlds of machine learning research and libraries is a key library competency, which is public pedagogy. As central nodes between the research, educational, and public sectors, libraries could play an integral role in helping the wider machine learning field develop, test, and deploy explainable machine learning systems. As Michael Ridley noted, quote, "It is concerning that these machine learning innovations are happening outside the field of academic librarianship with little or no involvement of library expertise." Practically and specifically, we might look toward human-computer interaction as expressed through digital library interface design as a site for explainable AI that offers paths into cultural heritage collections while educating users about the research method that generated those pathways. Where computer scientists bring experts in machine learning methods, libraries understand information literacy and can help construct interfaces that communicate machine learning data to a wide range of prospective users. Oh. There we go. Oh, there we go. So I'm guided here by Michael Whitelaw's work on generous interfaces that, by contrast to keyword search, invite exploration and support browsing. Give folks a second to look at that. And also by Bethany Novissi's call for digital libraries that, quote, hold unpredictability in mind and admit alternate futures. Prioritizing generosity, exploration, unpredictability, and technological explanation may require interfaces that prioritize transparency, even a kind of awkward transparency over polish. Some of the best projects on explainability I survey on the report are those with creative, activist, or even weird outputs. And so some of the projects that I look at are things like the Neural Neighbors project at Yale that allows folks to browse this collection of photographs based on similarity of sort of composition and the images themselves. At the current moment, this doesn't exactly point right back into the catalog in the ways that I might wish, but it's the idea of this sort of, exploratory interface. I look at things like Taylor Arnold and Lauren Tilton's Distant Viewing Project, which allows you to look at film based on who's in scenes, who enters, who leaves. I can imagine a sort of way into a film collection that actually uses these features in order to allow folks to zoom in on particular moments that they're interested in across a lot of films. One of the interfaces I was most excited about is the Dig That Lick interface from A Pattern History of Jazz that allows you to, within a music library, to browse by riffs, musical riffs that are repeated in multiple songs. I'm not going to try and play it here live, but it's one of the most interesting interfaces that I came across for getting into a collection in a new way. And again, as you look at it, right, it doesn't maybe have the polish of like a commercial interface, but actually it genuinely allows browsing based on the results of machine learning in a novel and exciting way. Oh, actually, I guess, I don't know if people can hear that. I don't know if people can hear my screen. So you get the sense of that. I was moved by projects like Transcribus that are trying to build new OCR models by having scholars contribute their own training data, essentially. And if enough training data in a domain is contributed, they'll build a model and share that back with the scholar. And the Newspaper Navigator project, which is quite new from the Library of Congress, which allows folks to browse the images and other features in newspapers in ways that are beyond what the search bar in Chronicling America's web interface might enable. And I said also sort of, just sort of weird and fun outputs. I'm really struck by things like the AI weirdness blog run by Janelle Shane, which, trains a model to do things like generate recipes from a collection of recipes or generate names of hamsters from a collection of pet names, things like that. These sorts of projects they're sort of fun and silly, but I also think that they help just general users get a sense of how a model builds its understanding of a collection and then reflects that understanding back to users. And so what I'm calling for is libraries doing more of this sort of iterative and sort of weird experimentation. And then we can also point to more activist sorts of projects like those done by the Algorithmic Justice League that highlight the inequities in AI and machine learning systems through art installations, through technical projects, as sort of a range of outputs that dramatize these biases to people in ways that help them understand in the way that purely academic writing might not. So I look at these sorts of projects because they're as much about interrogating the possibilities and the limitations of their underlying technologies as they are about the aesthetic objects that are created. And as such, these experiments are intriguing models of explainable machine learning in which readers or hearers or users come to better understand how machine learning works through engagement with the sometimes strange, sometimes delightful, and sometimes unsettling artifacts that it produces. We need speculative library interfaces that forefront their createdness and ask patrons to better understand both cultural heritage data and the methods through conscious exploration of sometimes enlightening and sometimes frustrating creations. Machine learning interfaces could explicitly report, for instance, the confidence scores for the relationships, annotations, or other metadata determined through a machine learning algorithm, seek to make users more aware rather than less aware of the probabilistic bias of the data, and perhaps even seek user contributions to improve processes in future iterations. I contrast this approach with the OCR that underlies most large-scale digital archives, which tend to hide the OCR beneath the interface. It's not forefronted, and to provide very little context about the specific OCR processes or the reliability of the data. So OCR is integrated across library systems, but it tends to actually not be talked about and to be hidden and only discovered by researchers once they really delve in and they run into a problem or the OCR is not working well. Oh, sorry. So I want to focus here on this slide. This article is useful. The aim of this reporting, to report on confidence scores and so forth, is not simply to cast doubt, though skepticism is healthy in this domain, but to make presentations of machine learning data opportunities for cultivating literacy. Helping users understand the confidence rating behind a particular label or category contextualizes any claims that they might make from that data, and a sense of the machine learning's limitations could, perhaps counterintuitively, serve to increase overall confidence in machine learning because its claims will be understood as contextual and relational rather than some kind of totalizing claim at truth. Through the cultivation of explaining machine learning integrated interfaces, libraries can meet their goal of cultivating information literacy among their patrons. So I really am moved by the different framings of computing in this article, thinking about computing not just as a analytical tool, but as a diagnostic, a formalizer that actually can illustrate limitations and gaps as much as it can make analytical knowledge claims. Right? I also take UCL Joe and Timnit Grubu's claim that libraries and archival studies have institutional and procedural structures in place that regulate data collection, annotation, and preservation that machine learning can draw from. And so I suggest that building on their roles as hubs of intellectual exchange, libraries can become focal sites for the translation of machine learning research to the public and leaders in discussions around explainable AI. So much machine learning research with library data to date, computing has been this tool for analysis only, illuminating patterns in particular genres, time periods, and so forth. But I suggest that it could instead serve as a diagnostic to the problems inherent in existing digital collections, a rebuttal to machine learning work that is falsely claiming objectivity, or a synecdoche that helps patrons better understand the historical stakes of library collections and archives. Speculative views and interfaces into machine learning derived data can make these functions plain to both researchers, library patrons, students, and the public. And sort of the last thing, this is just a bit more off the cuff, but thinking about our own work in viral text, right? We've done some work taking snippets from newspapers and building models of genre and trying to classify genres, right? But thinking about how this would get integrated back into an interface, the reality is that a text doesn't just get put into one genre with 100% confidence, right? If you have 4 different genre models and you run it across a text, then you get a probability for all 4 of those genres in those texts. And so I'm imagining an interface that would allow users to adjust both how confident, I want to see things that are at least 74% confidence that they're poetry, or at least 80%. But they would also see the overlapping predictions that are being made across genres, right? So it does allow users to explore particular genres within the collection, but while doing that, they're learning something about the multiple possibilities actually for each text that have been classified. And we currently are working on a sort of experimental overlay interface where someone browsing Chronicling America would be able to see the likely reprints that we've identified, but also with information about how we determine what is a reprint algorithmically, and the point back to descriptions for those users who are interested. And the idea is ultimately to meet users at different levels with different amounts of detail about the methods. Okay, I think that I am right at time, and those are my prepared remarks for today. But I look forward to, if we have a question period, any questions we might have.